Hello, and welcome to Grade 7 Science Intro to Geologic Dating. This is Mr. Brocklehurst. When putting together an accurate picture of Earth's history, scientists look for clues to tell them the order in which events have taken place. They do this in two ways, relative dating and absolute dating. First, we'll take a look at what relative dating means.
Okay, let's chat about relative dating for a while. When we introduced it in the evolution unit, we never really got to the reason why it works and what it does and any of the complications or limitations to it. Today we'll be getting into more of those details. Relative dating doesn't have to be geological necessarily. It just means that you're comparing the ages of things when you don't actually know any of their ages. You might ask how this is possible. That's a great question. I'll try to illustrate it with an example.
Alright, now take a look at these guys. I've placed them in no particular order. See if you can put them in order from youngest to oldest. I'll wait a few seconds while you sort them out. Okay, if you said D, B, A, then C, then you put them in the same order as a whole lot of other people. Notice that we were all able to do this, and none of us ever really knew any of their ages. This is relatively dating, and we'll be doing it with rocks next.
Look at these rocks. Do you think it will be easy, or that we'll have as much agreement about the order of which is the youngest and which is the oldest? Rocks are much harder to date by looking at them. So you remember how geologists generally rank rocks in the earth by their age? You might remember that they use something called the principle of superposition. That basically states that rocks that are buried deeper are generally older than rocks that are buried more shallow. This only applies, however, in undisturbed areas. Now, an important limitation to this is that the area can't be disturbed. So what do we mean by disturbed? Well, when scientists see an area where the rock strata or the layers have not been disturbed, and all the layers are present, they call it a geologic column. Scientists can also create a geologic column on their own just by looking at different areas that have been disturbed and rearranging those layers in order from oldest to youngest so that they appear in a way that is no longer disturbed. Welcome back, everyone. Superposition is simple to do, but as with most simple things, it does have its limitations. Among them, you never really know the ages of the rocks. You've only made comparisons of their ages. It only works this easy when the area hasn't been disturbed as well.
You may be asking yourself, what types of things would disturb the strata of stone? Well, probably some of the things you'd expect, but maybe one or two that you wouldn't. Things like earthquakes. Also, the movement of tectonic plates. Those can force some of the younger rock underneath the older rock, or even uplift older rock. Also, magma. Magma might get pushed up from the mantle and then cool down at the same level as older rock. And finally, erosion. Erosion can completely erase or misplace rocks in the column.
Take a look at these different disturbances. What could have caused them? Well, you might have come up with a short list if it included earthquakes, tectonic plate movement, or other internal forces of the earth. You would have matched with us.
All of those seem relatively straightforward, but a more complicated disturbance is when magma gets pushed up and cools below the surface. One last disturbance that we'll take a look at is when a layer of the strata is completely missing. And this is because of erosion or just a lack of sediments being deposited. When this happens, we call it an unconformity. It represents a missing gap in the rock sequence. And for many geologists, it also means missing time, since we don't have any record of what took place at that point.